We'll get started. Appreciate everyone showing up today to hear this talk this afternoon. So I'm Paul Coggin. My background is network security architect. Spent a lot of time doing penetration tests, architecture reviews, telco service provider. Mostly working at layers 1 through 3 of OSI models, where I spent the majority of my career either building the networks or trying to figure out how to secure or break into the networks. So this talk is inspired by a lot of the engagements that I've been involved with over the years, getting called in to respond to problems after a customer might have been hacked, or just various projects. And one of the things I've noticed, that no matter how experienced the pen test team may be, and a lot of times, or the network might be compliant, might have been secured, that the layer 2 of the OSI model is missed. A lot of the focus is on those higher layers because we have all the automated tools to knock out that low-hanging fruit, going scanning and enumerating the Windows boxes. But in many cases, we're missing that low-hanging fruit that just pulling up Wireshark will catch. And I got inspired to do this engagement because I worked on a really large network, Juniper, Brocade, Cisco, huge network. And lots of stuff popped, and we just went in after the engagement was almost completely over with, and just started pulling up Wireshark, and then within just a few minutes, literally, just took a few minutes, and just like 7, 8 high-level vulnerabilities picked up as fast as Wireshark could capture it on the wire. And these things, and it just made me just realize how much it's being missed in so many of the networks that are being audited and tested. And so we want to point out some things to you to make sure that we're doing due diligence and working the whole OSI model stack and not just looking at those higher layers, say, layer 4 up. Here's something I was at a security conference we'll just say in the last few years I was at a security conference at a hotel. I was teaching. One of the guys in the class, I was talking about pulling up Wireshark, and he started pulled up his what we call CDP protocol here. And in the network world, as Cisco guys, we use the CDP protocol to understand what is on the other side of a network link. We can tell whether you can log into a router or switch, and you can tell what other kind of router or switch you might be logged into or only connected to, so that you can map out that network. Because everybody's got a network drawing, but it's never up to date. But you could use CDP to go and map out what is actually there. And if you're in an anything but Cisco shop, it would be LLDP on your HP, Adtran, what have you. But in the Cisco world, we'd use CDP, and it's going to go and tell you lots of information about that device, tell you about the routers, the switch, the software, what kind of hardware platform it is, what interfaces you're connected into, and where you can go and understand your network and say if you're troubleshooting. But from a pen test standpoint, or if you're doing a vulnerability assessment, this is great intel to understand what's happening on the network, because it's being multicast out on the wire. It's not crossing routers. It's staying in that local VLAN that you've got access to. And if you'll just pull up Wireshark, in many cases, you'll see the LLDP, or you're going to see the CDP. And in this case, when I was at this hotel teaching the class, the student pulled up the CDP, and we started having a conversation looking at it, and he went and started doing a Google on that version of code that was being showed here in CDP. It was a different version of code for this instance. And there was like 5 vulnerabilities running on that code, 5 major vulnerabilities, just out there, low-hanging fruit. And it was at a hacker conference. And you got 5, and the hotel's got 5 major vulnerabilities on their core infrastructure being multicast out on the wire. They supposedly had been tested recently and secured, had a whole new network put in, did all the right things. It's what I call the VPT, the vendor persistent threat. The vendor went, sold them a bunch of stuff. The vendor went and sold them a bunch of stuff, and it was all secure, because if you don't believe it, look at the quote they gave them. They told them they're going to implement a secure network, probably put in all kinds of blinky lights. But this right here is your low-hanging fruit, 5 vulnerabilities just discovered with just a simple capture. Here's something that's being missed by a lot of folks. Multicast is coming on, and it's a very popular protocol. From a security standpoint, we need to get after this. With multicast, if you're not a network guy, let me give you a quick crash course on multicast. With multicast, we have the layer 2, what's happening in local VLANs, but we also have it in the routing. Basically what we're doing with multicast, instead of sending a stream for each individual subscriber that's interested in some content, we can send one stream from the source, and then it gets replicated. So it's a one-to-many type architecture what we get with multicast. It has tons of applications. Where I spent most of my time working with multicast, where I really learned it was in the cable TV industry. I spent many years helping cable telephone companies get into the cable TV business, where we would map TV channels. When you're sitting at home hitting your clicker, what you're most likely doing is your TV channels are mapped actually to an IP multicast group. So when you're hitting their clicker, you're changing IP multicast streams. And that's where I learned it from, so that it could be one-to-many. So they got one stream headed out to thousands of their customers. And there's lots of other applications, say in tactical networks, say the stock market, et cetera, where you may see multicast. And so when it starts hitting your routers, in the routed world, you're going to have, there's going to be a protocol called PIM that's going to be used. There's multiple variants of PIM that can be used, and PIM is dependent on your routing protocols. And your routing protocols, typically, it's going to forward traffic based on the destination. With multicast, it's going to make a decision whether it's going to forward traffic based on the source. If it cannot go and track back a source that is trying to source multicast traffic and stream it on the network, if it cannot see it in the routing table, a path back to that source, then it won't forward it. It's called the reverse path forward rule. And so multicast is a little different in the way of thinking when it comes to the routing, but know that the multicast is depending on your routing, like your OSPF, your EIGRP, what have you, or your BGP. It's got that dependency. And so that's what's happening. And then, from a security standpoint, whether you guys are auditors, if you're the C&D guys, you're the blue team, one thing I want you to look at, and I'm going to show you some slides of, is these routers bleeding and leaking out too much information in here to these user VLANs here. And then what's happening down here in the user VLANs, down here at your layer 2 that we're primarily going to talk about, is whether it's your set-top box at home or some other multicast application you have at your work, they're going to be joining and sending requests to join multicast streams, and it's going to, those requests will go up and hit the router, and the router they'll go and calculate an algorithm, determine how the forward traffic through the network and get it to the subscribers needing traffic. But what if you have some subscribers that have access to their computer? Like most of the networks I've spent my career working in, we have full-blown access and we can go and do whatever we want to do. Or if you don't, you could bring in a computer from home. You got developers that have access to the network, and God knows what those developers are writing code for. And what's to keep someone from perpetrating another subscriber on the network and sending requests up to the routers to pull more traffic than you could possibly really need and be to support on that network? And that's going to be happening with that IGMP protocol. That's what you're going to see in the layer 2. So here's a quick PCAP. What you guys want to look for, whether you're blue or red, whatever team you're working on, you want to go and pull up that Wireshark and look for that IGMP. Are you seeing IGMP? Do you know that your company, your organization, your .com, .net, .org, whatever, .gov, .mil, whatever you might be a part of, should you be seeing this IGMP traffic? Do you actually have approved multicast applications out there? Why are you seeing it? And then go and ask yourself, is it secure? Are we using a secure version? Are we doing version 1, version 2, version 3? How is that implemented? And then, at the same time, I showed you on that architecture, those routers, when those routers tie into where those subscriber VLANs, are you seeing the PIM protocol, the multicast routing protocol? And if you are, why? The only reason that you should be seeing the PIM protocol, if you're out there doing auditing or pen testing, is if they have redundant routers terminating into that VLAN where your users are, because then the routers would be talking to each other for redundancy, for failover. But the question we need to ask ourselves as auditors and defenders and the red team, if maybe I spend most of my time these days on red team, I want to ask myself, what is that attack surface there? Did they implement it correctly? What does those router configs look like? Did they harden that trust relationship? Because I see this here, I got to start asking myself the question, and we need to go and start interrogating those network guys. As painful as it is to go and deal with those network guys, I can say it because I'm one. Network guys don't like anybody getting in our business when it comes to security. We know everything, just ask us. We know access lists, we know subnetting, we got it. We know BGP, we got it. But we really need to interrogate them, because that's what I spend like a good living at, is breaking into the networks that have got it, because they don't got it. You need to go probe it. So here's how we might be go a crash course of some ideas on how to possibly go and attack multicast. On that IGMP, you guys that have been through SANS training, you know how to use scapping. Why could we not go and take some of those packets, understand the structure, and go script up a tool in scapping, write us some Python, and automate sending, enumerating multicast, and just going out and enumerating different multicast groups that we may become aware of through Recon, and pull traffic, subscribe to traffic, and pull down into that VLAN and cause the network to possibly melt down. I have personally seen, I had responded to an incident many years ago where a developer, he was not being malicious at all, he was doing his job, was developing network code, and he was doing a multicast application, and he melted a large enterprise down. And this place had the most expensive blinky lights you could put in the network. I mean, it was a beautiful network. And the developer rolled the whole thing over with a multicast storm that he accidentally created. So have we gone? So that's a vector. And then from the routing standpoint, what if they have these trust relationships are open? Why can we not go and act like a router? If they're sending routing protocols down into the VLAN where the subscribers can see them, and they have not locked down that trust relationship, why can we not go and boot up Coggin in a VM, or go and download some code and fire up GNS3 and look like a Cisco router, or fire up a Juniper router, go get on eBay and buy a router, and join their network. And not only, join the OSPF, join the IGRP, whatever they have, and join the PIM conversation and inject a whole new source. Now, I will warn you, before you do attack some of this type of attacks, you need to make sure it's in your scope of work and in your rules of engagement, because you don't want to be that guy that rolls over the production network. Because if you make that help desk light up, everything's off. You're going to get to meet those executives that you might have just seen pictures of and seen memos from. Yeah, you're going to get to meet them. It's going to be a really interesting conversation. I've met these people. I might have been in places where networks got rolled over in my younger days out of ignorance and enthusiasm, youthful enthusiasm. There's lots of stories I could tell you. Maybe later, and I can tell you some stories. But we could go and easily craft these packets to go and perpetrate a router and manipulate the PIM protocol. So what we want to do from a defender standpoint, if we're going, we start seeing this, when we go to audit it, we want to go and hold these network guys accountable and make them give up those router configs, make them give up those switch configs, go and collect PCAP and go and hit different VLANs and audit these networks and prove out that they've actually secured this network infrastructure and lock down that trust relationship, both at layer 2 and layer 3, to make sure somebody's not spoofing traffic. What about at layer 2? We're in the same VLAN, what is to keep me from spoofing your IP address in the VLAN and subscribing to multicast traffic and make it look like you as the one that is killing the network? I'm not hitting the router. I'm just sending that first hop, telling the router I want that multicast stream, and I'm making it look like you. The only thing that could point back to you is the MAC address. And I can tell you this is low-hanging fruit, because most places have bought the most expensive blinky lights. They bought the Brocade, the Juniper, the Cisco, but they've not implemented the layer 2 security, or because a lot of the organizations are very scared to turn on layer 2 security. And so this is something that this is low-hanging fruit for you guys that are out there doing auditing in pen testing. There's another piece of this is some old school stuff. I mean, this has been around since Ethernet. I mean, geez, everybody's worried about day zeros, and we haven't dealt with day 80s. But anyway, you go and you pull up the Wireshark, you see the span tree. I've seen multiple networks when I was doing consulting. Multiple networks get taken out with span tree, and what the whole span tree is, again, is layer 2. And we've got these people, I call them the flat earth people, where they build these huge, enormous flat networks across campuses, across their large manufacturing organizations. And what happens, you got all these switches that are put together, and then you got the spanning tree protocol that a lady named Radia Perlman developed back when she worked for Digital Equipment, so that we could go and do a calculation to find the loops in the network and then kill that loop in the network. And it works real efficient. There's multiple versions of spanning tree but it's still some low-hanging fruit to go target. And I personally have seen a really expensive network, a large network for our manufacturing organization get taken out because somebody went to Best Buy and they bought one of those bridge/router/access point/toaster microwave boxes, you can get at Best Buy, and plugged into the network, and it had a lower bridge ID, and the network reconverged to that little, $50 switch, and rolled the production over. I mean, just like, geez. And that's easy to mitigate. Again, you've got the tools in most of your network, your HPs, your Juniper, your Cisco, your Brocades. The tools are there. We bought the blinky lights. The CIO paid for it. We sold them on it because we all wanted, in my case, I wanted Cisco on my resume. Because you get that, go and do a lookup on Munster and all, hey, the Cisco guys get jobs, right? But we bought these blinky lights, but we haven't configured them and secured them. So here's another example. Some things that are being overlooked when it comes to the layer 2 protocols is like dynamic trunking protocol, where you can dynamically, the switches will dynamically go into VLAN trunking, where you can multiplex multiple VLANs across an Ethernet port. Like, think about like your voice over IP phone, where you got a VLAN for your PC, you got a VLAN for voice, it gets multiplexed down the line. You got that, so dynamically will adjust. Well, with that DTP protocol, if he'll talk that protocol, why can I not spoof that protocol and craft packets using, say, SCAPI, or if you're Windows impaired like me, Colosoft Packet Builder, and point and click and send packets up the wire, or frames in this case, since we're doing Ethernet, up the wire, and to manipulate that switch to drop us into a VLAN that we were not supposed to be in. Things that we need to be looking at, and we're missing it when we go out and do audits. We're out there doing audits. Now, if you're doing pen testing, this is one of those things, again, you need to go and make a suggestion to go look at. I probably wouldn't go, and some of these things I wouldn't do in a normal pen test, but unless it's specifically in my rules of engagement. Another thing we could do is, how about going and taking a tool like Yersinia? If you're not good with Python, you don't know SCAPI yet, you could go download Yersinia. It's on your Kali distro, and do double VLAN tagging, so they got you dropped into VLAN 10, but we know that there's some interesting systems over in VLAN 40. Maybe we know we're fixing to get fired. If we want to take the network out, we want to, we got a rogue employee, and he knows that over, say, he's in VLAN 10, but he wants to go and get to a server in VLAN 40 on his way out the door. He could go in and use his Yersinia, double tag himself. The switch removes, say, that outer VLAN tag, and then shoots himself over into the VLAN that he wanted to be in, the VLAN 40. He just jumped your VLANs and your trust relationships. So this is something, this again is a lot of, whenever I create slides, something you need to know about me is if I create slides, there's a story behind it. There are people behind these slides, and so this one, another big network, we have the VTP protocol where we go and centralize. We go on one switch. This is some old school stuff. We go on one switch, create all of our VLANs, and then we're going to set up trunking, and the VLANs can get propagated down to our client switches. And it makes it really easy where we got a centralized place to build our networks using the VTP. But here's the problem. Here's the problem. It's real nice and convenient. We can go and create all our VLANs, and then we can propagate it down and associate, et cetera. But what happens, how many of the networks that you go out there and audit, you know that they're using the defaults, which are blank or whatever they learned when they were taking a course? And what happens here is in this case, there was a customer, they had a huge network, and they had a lab network. And they were always in that lab network making changes, which would update in this case, the VTP, the virtual trunking protocol. It would update that database, so they had a higher rev of that database, and they had a network switch go out. And so the network bubba goes and plugs in the lab switch into the production network. He did not secure the VTP domain password, the VTP domain, and have it separate from what they were using in the lab. It was using the same one, same VTP domain name, and he did not have a password on the VTP protocol. So when he plugged in that switch from the lab, it synced the databases up, and the lab switch overwrote the production switch, lost all the VLANs. He got to meet the CEO that day. I got to meet him as well because I'm the network guy that called in to help him fix it. He ended up getting another job. I gave him a recommendation because I knew that he would never do that again. But it was terrible. It was terrible, because like most places, everybody's got documentation until the network crashes or something like that happens. So this is another thing from an audit standpoint. You guys that are out there doing audits, you're doing that vulnerability assessments, you're doing architecture reviews, you got to dig into those switches and get all of the configs, get all of the information. Don't take that network drawing on a napkin. Go in there and manually verify this. If you're in an insanely huge network, do a statistical sample, but get this information and audit these guys. And this, again, is one of those examples from a pen test standpoint, a red team engagement. You would never want to go do this to a production environment. You might go and put it in a lab and show the teams in the lab, for your own salary continuation program. You want to keep your job. So here's something really important. This is overlooked by all of the network gurus, ninjas. Broadcast storms. We put in these expensive blinky lights, and we've not put in the controls to throttle this multicast traffic that we were talking about earlier, or the broadcast traffic. And you can also throttle the unicast traffic. There was a piece of critical infrastructure, a major piece of critical infrastructure. I know this happening in two places, once in Europe and once in the Southeast. And it happened in the utility. I'll just leave it at the utility industry. A misbehaving device took out a huge network. One of them I'm familiar with, they had to do an emergency shutdown. You let your mind roam around where that is. This was all out on the web not too long ago, some articles I read, because they had the blinky lights. The organization is huge enough that they would have the managed switches with all the features and knobs, but they did not turn this on, and because there was not there a malfunction device caused an emergency shutdown of a ICS SCADA control system network. And then there was a network in Europe that got knocked out, similarly. A smart grid network, huge smart grid network got knocked out due to a similar vulnerability because they just didn't turn on to limit broadcast storms. Now, this is one of my favorites. If you get into a large enterprise, you're going large organizations where they have a large enough network where they understand the need for redundancy. You're going to have routers set up in parallel, so that if one router fails, the second one will automatically pick up. If you're in an anything but Cisco shop, they're going to be using the VRRP protocol. If you're in a hardcore Cisco shop, if you've got a Cisco guy on staff like me, it's going to be HSRP that they're using most likely. And then there's another protocol, GLBP, that you might be using for global load balancing. And what happens is these routers are going to be multicasting between them, and they're going to send a heartbeat between each other, and everyone in that VLAN is going to see it. And that's basically the default gateway, what they're going to be sharing between each other. And if one of the routers fails, the backup will automatically pick it up. Now here's a quick peek out of what you might see if you guys are out there auditing of VRRP, and it's showing no authentication here. You can just pull up a PCAP and you see the VRRP, and you can expand it and you'll see no authentication. If they're doing authentication, it's going to be clear text. I have never, in my career, I've been doing pen testing, architecture reviews, security consulting since 1999 is when I got into the consulting security business. I've never seen these network protocols hashed and encrypted until after they've gotten one of our reports. And I've been all over the world. I plugged into so many networks, ain't no telling what my computers have gotten from those networks, but they're a big science project in themselves. But they're either always no authentication, which is predominant, or it's going to be clear text authentication between the devices. And then But don't worry about there being a hash. There won't be a hash. If you see a hash, somebody's got a hold of them. They probably have sat through some of my talks and then went and audited some of their customers. So with the HSRP, here's what the HSRP is going to look like. This is you pull up the PCAP, and most of the time it's going to be like the vendor's name, like Cisco, or it's going to be the name of the organization, something like that. And it's going to be in the clear if they're even using authentication. So what can you do? Now, I want to break this down to how simple it is, because you're going and you have these conversations with when you start talking to execs, you're talking to the people who own these assets, and they want to go in and negate the importance of it. This is how easy it is. You go download, you go and pull up Wireshark, open up your Wireshark, get you a quick PCAP. You go to Colosoft and you download a packet builder. You put that in, and as quick as you can go and click on a packet, you can change the IP address here. You could go and change the IP address of one of the routers in that PCAP. You just go edit it. I mean, live edit it, and go in and change the priority. Say the priority is 100 on one router, 110 on another router. Typically is what you're going to see. The highest priority is 255. Nobody ever uses that. It's always some lower level number, so they're going to let you have the highest number. It's there, use it. You go change that, and then in your Windows tool, because you're not lead if you don't do it in Linux, right? But we can do it in Windows. This is so easy, a Windows guy can do it, I want to break this down. We've got to fix this stuff. We've got to clean these freaking networks up, guys. And so we go in and rebuild the checksum on the packet, fire it, baby. You are now the router on the network. If you're taking notes and you're going to go do this to someone, if you're authorized on your scope, rules of engagement, remember to turn on IP forwarding, whether you do this attack with SCAPI on your Linux box or you do Windows, go in and turn on IP forwarding, otherwise you're going to be the bit bucket. And again, we're going to light up that help desk, and it's going to be the long walk to the C-level guy's office, his conference room for a meeting. Maybe the salary continuation program will keep working for you after that meeting, maybe not, I don't know. But this is how easy it is. But you could easily, I would encourage you to learn how to do these things with SCAPI because because it's so powerful. But if you need something quick and dirty, this is how easy it is. IPv6, nobody's running IPv6. You ask all the enterprises, nobody's doing an IPv6 until you open up Wireshark. Again, this is some low-hanging fruit for you guys that are out there doing audits, and you guys that are just trying to get into the industry. You're going behind those guys with all with the resume. The whole first page of the resume is all their certs. This is some low-hanging fruit because everybody's metasploiting. Everybody's and that's all good tools and that's all great and it needs to be done and it needs to be audited. But there's more to this. There's this whole OSI model in burp and Metasploit. They're wonderful at those higher level stack. But we'll miss layer 2 and layer 3 here, guys. So we got the V6 going. It's some low-hanging fruit. Majority of the networks you plug into, you could go in easily. There's routers out there sending router advertisements. You can go and these hosts are out there sending DHCP V6 requests, and you could easily go and send router advertisements. Again, pick your tool. The one I would recommend to respond to the end users sending out these multicast packets looking for a router. Check out Chiron. Some guys over in Europe. I know Antonio out of Greece and Eno Ray, the guys from ERNW. Developed this tool, Chiron. You can check out Evil Foca. And you could go and turn around, you had the old school Kah and Adrian EtherCap man in the middle. Well, this is how you're going to do that man in the middle attack with IPv6. And this is low hanging fruit. And this is going to work, and you're not going to knock the network out if you do it correctly. And then you can basically do a man in the middle between the router and the host. And similarly, again, we don't have the Kah and Adrian EtherCap ARP poison attacks with IPv6 because we're doing multicast now. We're not doing broadcast with IPv6. Well, when those neighbors, say the host and the VLAN want to communicate with each other, well, there's the neighbor discovery protocol that you're also seeing out there in the wire that we could go spoof easily, again, with Chiron, Evil Foca. If you're got elite Python skills, you might go and use SCAPI. I'm just going to pull up whatever's easy. I'm lazy. I'm going to pull up whatever's got a GUI, point and click, and fire. So again, going back to layer 2, here's something where we're really missing it. We're going into organizations and doing audits, and they're paying the top companies in the world to come in and audit their networks and implement data centers, the cloud, the private cloud, the hybrid cloud, the public clouds. Everybody's doing clouds, right? It's cloud craziness. Well, you get into this cloud, regardless of whatever your vendors and whoever, the VPT that you've bought, that vendor persistent threat that's doing the cloud for you. Here, when you go in, what we're seeing, what I've seen in the past, is you get in that cloud, if you can just get one handhold in that network, it is just one big flat network. The flat earth guy was on the cloud team. He's gone and got him a Microsoft Cloud cert or a VMware cert, and now he's a cloud guy. So he's a flat cloud guy now, I guess. And if you can just get one handhold in, you can pivot horizontally at will through these DMZs and these network segments and spread influence. And an example I'll give you here is also, and at the same time, if you can get off into that DMZ, and if you will start pivoting horizontally, you will find that there's a ton of trust relationships waiting to be discovered back into the more sensitive networks once you get that initial handhold, because the flat earth guys have convinced everyone that nobody's going to break into the DMZ, and if they did, they're not going to be able to do anything. And so nobody goes and secures all those trust relationships back through the firewall, back into the keys of the kingdom. So an example, went into one organization, they were doing business-to-business transactions of some billing information. There was no reason for anyone other than these two IP addresses of these two organizations to communicate. They had it wide open. We discovered it, went in and hit them with a JBoss attack, got a command shell, and discovered. And this is the reason you got to keep some old crusty network guys like me around, guys that know Solaris. This is the reason they kept the network bubba around, because I knew things like Solaris when they got into, because the kids got into this JBoss, and it was running on Solaris, and they didn't know what to do with Solaris. What is a Solaris? They know Linux, but they don't know Solaris. Well, the old network bubba knows Solaris. There's a trick. You got Active Directory on Windows. In the Unix world, you got what's called NIS, which predates LDP. For you young guys, there's this thing called NIS, Network Information Services, that they use for Unix services, for a directory service. And it turns out, if you could get a user level privilege on one of these boxes, like a Solaris box, running NIS version 1, you could get it to spit out the shadow file with user level privilege. And so we were able to get that, and we're able to pivot at will through this network, because we dumped all their password hashes. And there's another thing I want you to know about this. A quick tip is, I have never in my career found NIS, a Solaris box. If you find a Solaris box out there where you can touch it, I will buy your lunch. I will buy your dinner when I'm in town. Hit me. Hey, I owe it to you if you can show me that they're not doing Active Directory integration with their NIS with that Solaris box. And what that's going to tell you is you're going to know that they got an 8-character password. So when you find a vulnerability and you're able to dump those password hashes off that Solaris box, you know that to pop the Windows boxes, all you got to do is crack 8 characters. We're off to the races, baby. We're going to be screenshots. It's going to be a PowerPoint deck this thick when we get done with this project. So there's some things on the, but to lock that down, go and use things like private VLANs, VLAN access lists, because some of these networks you can't go and reverse engineer and undo them after they've been put in place. They're too huge, they're too sprawling. So we could go in without going and redoing subnets, things we could go in and lock down that layer 2 with private VLAN. And you could go and use, like VMware's got the capability they support. With your NSX, you can go in and lock down that layer 2. And if you're in say a Cisco, Brocade, Juniper network, you could go and lock down your layer 2. No reason not to. Here's the big thing. Got to get visualization on this network at layer 2, not just layer 3 at the major choke points in the network, at the aggregation and core, but get it down to, get visibility down there in layer 2 at the edge. How do we know what those users are doing, that insider threat? I saw some statistics the other day from SANS that coming from the field that like over 30% of the security guys are seeing insider threat. But those insider threats are sitting out there on those layer 2 those VLANs. Do we have visibility down there? How do we know what they're doing? We could be getting pillaged and plundered down there at layer 2, and we're looking for traffic, a couple router hops north, and we got all hell breaking loose down in a VLAN. Are we looking for that? Can we do the forensics? And and again, even at layer 2, going and lock down those trust relationships. And another big thing to drive home with you is I'm big into separation of roles and responsibilities. Put in network taps. If you got the budget, if you got a small network, you might not be able to budget it, but if you're in a mid-level large business, put in network taps. Because I can tell you as a network guy, I do not want to share access to my switches and my routers. That will get war started. There shall be war. There will be war before you get into my routers and switches. Don't fight that as a security professional. Drop in a tap. You're just an electrical bump in the wire. Drop in that electrical tap, pull off a 100% mirror copy of all that network traffic, and drop it into your own separate out-of-band network for security monitoring. And you totally avoid all those politics between the organizations about who has access to the routers and switches. People worried about, about access. Just drop in your taps. Cut all that politics out. Now, another thing I want to bring up real quick, you guys that are breaking into networks, that are working on the red teams and all, you need to make sure know about it on these routers, especially the Cisco stuff now. You can do packet capture directly off the router. You don't have to. You can do port mirroring. But you can go and do packet capture right off the router. So when you go and pop that router, you get enabled on that router. You could do what they call embedded packet capture and capture PCAP right off that router and start gaining intel on clear text protocols, et cetera, whatever they have. You don't have to have that local VLAN access and it would say Wireshark, et cetera, to get and get net flow. If you're not collecting net flow, I will patronize you, I will humor you, but I will laugh at you as I'm leaving, shaking my head, thinking they have no idea who all's in their network. You've got to get the net flow. Or if you're in anything but Cisco shop, the J flow, the S flow, but you got to get flow in that network. And I'm a huge believer in LAN cope. If you got the budget, get LAN cope. It rocks. There's some other good stuff out there that I don't have the experience with everything. SolarWinds is good. Scrutinizer is good. But my favorite that I've worked with personally is the LAN cope. It rocks. That Cisco LAN. There's a reason Cisco bought them and used them before they ever bought them. The stuff's very good. Well, let me point this out real quick. When you're either attacking the network or you're trying to secure the network, I want you to look at that OSI model, and I want you to go and look at each layer of the model from the standpoint of the control plane, the data plane, and the management plane. Those 3 planes for each layer. How is it being managed? What are the control protocols, those network protocols? And then the data traffic. Look at all 3 of those. Ask yourself and pull that thread for both in-band and out-of-band, and you will find holes in your network. And if you're on the red team, if you're the pen tester, you're going to find a way to break into that network. Nobody's done it all right. And all you got to do is just take that stack and look at those 3 things: secure the control plane, data plane, management plane. Each layer, where did they screw up? Because they screwed up somewhere. Despite how many certifications and degrees they have on the resume, they messed up somewhere because they run out of time and budget like the rest of us. It's life. Life hits us all. So here's some references. Here, I can give you more, but here's some quick references. I highly recommend if you're into, especially you guys that are in the red team and you want to go and do a deep dive into pen testing and how some of this stuff works, Eno Ray and the guys at ERNW, they're one of my favorite references. Go out there and check out their work, and they run the We Are Troopers. They run the Troopers conference in Germany. It's awesome. Yvonne here, go check out iOS Hints. He's got an awesome blog site. He puts a wealth of information out on iOS hints. You can follow him on Twitter at iOS hints. Highly recommend that if you're interested in network infrastructure stuff. Follow those guys, and they will open your mind to a whole new world. They've helped me. So, what I've got. You guys got any questions? Yeah, I'll give you the slides. You hit me on, email me, hit me on Twitter, LinkedIn, what have you. I'll give you the slides. I'll give you all my slides. Give you a course I wrote, 2-day crash course. I'll give you everything. It's there to share. Any questions? All right. Well, I'll be around all weekend. Reach out to me if you see me hanging out. If you want to talk shop, tell me. Appreciate it.